Hello everyone, my name is Dipen and welcome to my talk. Today I'm going to be talking about how we design an autonomous workbench for our data science counterparts at Episource using AWS and the Jupyter project. So before we actually begin, a little bit about myself. I'm Dipen and I'm a member of the MLOps and data engineering team at Episource. Episource is a software organization that deals with healthcare data primarily. My primary areas of interest include container tech and MLOps in production. So let's talk about how why we needed a ML workbench in the first place. Um, so before we built our workbench, our data science team they used to train their experiments on ad hoc EC2 or SageMaker instances. However, we wanted them to be able to generate these development environments without DevOps intervention. We had multiple reasons for thinking so. The data science team they had to wait for someone from DevOps to launch an EC2 instance for them, tag it appropriately, and set up the environment and data they needed for their experiments and proceed with it. This led to greater turnaround times for building the features that were key to our ML pipelines. On the other hand, the DevOps team they had very little insight into the EC2 instance and why they were being launched, and when to retire them permanently or temporarily. Hence, we felt the need for some automation over here. So next, let's talk about the features that we were keen to build into our ML workbench. So first off, we had this in mind that we did not want to reinvent the solution, as a lot of projects had already covered what we were trying to build. So it was mostly just about customizing what fit us best. Secondly, we wanted the project to scale sensibly, as in it would scale up whenever the users were arriving, and and subsequently scale down whenever there was idleness in the platform. Thirdly, we wanted the users to experiment as freely as they could without worrying about breaking something. So personalized user boards was something that needed to be accounted for. Fourthly, we wanted users to get access to shared data sets whenever they needed. And then finally, we wanted to build this platform to be used exclusively by our ML team. So we had to shut off access for the rest of the organization, and of course the outside world. So arriving at the right picture. So we decided to use something called as Jupyterhub on Kubernetes. So first off, why Jupyterhub? Firstly, because all of our data scientists they were accustomed to using Jupyter notebooks for their local and shared development. Plus, it provides it provides a vast library of extensions that make ML development easier and faster. Secondly, the open source Jupyter community, they have built a lot of integrations with major orchestration frameworks like Kubernetes, in the form of spawners. So hence we decided to use the Cube Spawner project with AWS EKS, as it fit our requirements very well. So Cube Spawner is developed extensively in coordination with the Zero to Jupyterhub project. So we decided to go ahead with that. So once our basic workbench was ready, then we proceeded to add more customizations like auto shutdown and per user IAM roles, and volume mounts. So next, let's talk about the architecture in a little bit more detail. So when the user first logs in into the app, he's redirected to the GitHub app, which is a part of the Episource organization. So the GitHub app then checks if the user is a valid user. And if it is, the user is redirected to the server selection screen on Jupyterhub. So the Jupyterhub actually displays a screen asking the user to choose um, to choose between multiple options, like what kind of environment does he want, and what will be the size of the what will be the configurations of the selected server. For example, the CPU configurations, and if a GPU is required, and what is the memory specifications of the server that the user requires. Once these configurations are then locked down, the request is passed on to the Kubernetes, which selects a node from the node pool, which can fit the requirements of the user. Once the node is selected, and it's ready to host user pods, the Kubernetes asks ECR to for a copy of the Jupyter Hub notebook. And once the user pod is up and ready, the EFS persistent volume is used to set up the user file system. And finally, when all of this is complete, an IAM secret token, it is embedded onto the pod, so that the pod can may be able to use AWS services and the shared data. So next, let's talk about user storage in a little bit more detail. So each user gets their own EFS folder, which represents the data on their account. So whenever a user starts their Jupyter server, a persistent volume claim is created for them. And once, so this all happens automatically under the hood when the user logs in. Also, the user files are persisted even after the session is terminated for the user. So also we can attach more additional data sets to a user group pod by attaching extra persistent volumes. And at all times, the workbench is configured such that the EFS folders and persistent volumes, they are encrypted to protect the sensitive data. Next, let's talk about user management. The workbench management is taken care of by GitHub. So when it comes to GitHub, it ensures that only registered users of the Episource organization are able to log in into the workbench. So furthermore, to lock down access even a little bit more, an app level firewall also can restrict the access to members only specific to the MLT. In Jupyterhub, there's a special group of users called as Jupyter admins, which can view activity of other users and have access to all shared folders and individual folders. User access control. So this part specifically talks about how a user how users are able to access the data or the AWS services that are permissible to them. So the individual user pods, so to say, are using something called as Kubernetes service accounts. So these Kubernetes service accounts are in turn linked to a specific dedicated IAM role for that user. This ensures that each user can access only those data and only those services that they are authorized to. So let's talk about how the workbench has improved or impacted the ML development life cycles. Firstly, data scientists can now work with a single familiar Jupyter ecosystem across all stages of development, whether be it local development, training experiments, or even simulation testing. Furthermore, they can now access a higher tier of compute on the fly with an environment that is configured just to their needs. This means running high compute analysis jobs or training models that require the kind of resources that local development environments cannot provide. Furthermore, we have observed that it now takes lesser time for an idea to become a feature that is ready to be integrated into our ML pipelines. Since the Workbench now has automated capabilities for shutdown when idle and role-based access control, it tends to reduce the overhead for DevOps to monitor idle instances and cases of where sensitive data has been breached. Um, Finally, data scientists can now access and share files, data, and model checkpoints with much more ease, as they can just be moved to shared folders. So, what are the key takeaways from us as we built a workbench for data scientists? Um, Firstly, standing on the shoulders of giants, which means that you take inspiration and build on top of similar projects that solve these similar problems and remodel them so that they fit you best. Autonomy and self-service tools are the key which can help your ML team to succeed. Um, Thirdly, your design or your architecture may not look very perfect or may not work perfectly for your users. For example, a lot of our users were not satisfied with the initial iterations and of the workbench and were hesitant to use it. But we kind of took their feedback and iterated on top of it. So we eventually got to a point where we had the confidence of the data science team behind us. Finally, security aspects are a key part of your architecture, whether be it encryption at rest, encryption in transit, data sensitivity, role-based access control. They are very crucial aspects of your secure architecture. So I hope this presentation has been helpful to you, and it has inspired you to build your own workbench. Thank you.